The mid-infrared instrument on the James Webb Space Telescope is now at its super low operating temperature. The UK assembled instrument has reached a decidedly chilly -267 degrees centigrade, which is just 6 degrees above absolute zero. MIRI stands for Mid-Infrared Instrument, whose frigid status will allow the Webb Observatory to see the distant universe in unprecedented details. The temperature milestone confirmed by the US Space Agency NASA was hailed by the instrument's British co-principal investigator, Prof Gillian Wright. She said, "The cool-down process has been a validation of our thermal design. When you plan these things, you always have contingencies. There are what-ifs. How will you react if this happens or that happens? But it's been done in a single, straight shot. It's a really fascinating achievement." MIRI is not the only instrument. There are a total of 4 instruments on Webb. MIRI is the successor to the vulnerable Hubble Space Telescope and expected to be revolutionary. The Hubble was not equipped with any infrared instrument to capture the depths of the universe. A key difference is that Webb will be tuned to see the universe at longer wavelengths in the infrared. This means it must be protected from all heat sources, including its own hardware, which would otherwise glow in the same portion of the light spectrum it wants to detect. Webb deployed a giant sun shield shortly after it was launched on December 25, 2021. This tennis court-sized membrane put all the important parts of the telescope in the shade. This could keep the temperature of 3 of the instruments other than MIRI passively cool under -233 degrees centigrade. But for MIRI to work in the longest wavelengths, operating temperature should be less than 7 Kelvin, according to the director of the UK Astronomy Technology Centre in Edinburgh. If the temperature is above 7 Kelvin, then the inherent motion of the atoms inside the detector creates a charge, which is also called the dark current. To achieve the operating temperature, the engineers of a US aerospace manufacturer, Northrop Grumman, developed a cryocooler, which is a heat exchanger using helium as a working fluid to extract heat from inside of MIRI and dump it away from the instrument. The preparation for observations will start shortly after the MIRI team ensures that the 6.5 meter wide mirror is focused and all other instruments are calibrated. This process might take a couple of months. But once the James Webb is actively operational, MIRI will start delivering data from its camera and spectrographs, which will eventually give us great vistas of the cosmos like Hubble have done. The spectrographs will reveal the chemical compositions, temperatures, and physical parameters like density and velocity of the object in the view. The James Webb Telescope has a number of goals that include searching for the very first stars to shine in the universe and to study the formation of the galaxies in detail. It's time for Astronomy Word of the Day. Binary star. A binary star is a star system consisting of 2 stars orbiting around their common barycenter. Systems of 2 or more stars are called multiple star systems. These systems, especially when more distant, often appear to the unaided eye as a single point of light and are then revealed as binary or multiple by other means. Research over the last 2 centuries suggests that half or more of the visible stars are part of multiple star systems. A great example of binary star is Sirius binary star system. Here, the Sirius B can be clearly distinguished in the lower left corner. Thank you for watching, and if you like the video, please subscribe to my channel for more of such videos. Have a good day.